Good evening, ma. Yeah, we thank God, ma.
We are having a very important addition. We are making an alliance with Victoria Land today, and this is our first experience with Victoria Land. You know, we're FEMIA webinar series are also becoming part of their master classes, which is a very interesting thing. I would like to also introduce Christopher Cordova, who's actually the CEO of Victoria Land. Christopher, welcome. So if you can give us a little message, you know, we're very, very honored and we're very proud to have you here in our webinar series and being part of this new strategy with Victoria Land. And thank you, Christopher, and welcome. Welcome to all the Victoria Land.
Thank you, Luis, so much. We are extremely, extremely proud of this new partnership. And this is the first Victoria Masterclass we have. So we are absolutely, absolutely thrilled and happy of all the opportunities that will arise and that will come via this partnership. This is the moment where FEMIA and Victoria Land, and Victoria Ecosystems are joining forces so we can bring world-class training for all the members of the Victoria community. And at the same time, we can be working together so we can attract more talent to the aerospace industry. And of course, we can inspire wider audiences around the world on the aerospace and space science aspects. Thank you, FEMIA, so much. Thank you to all the members. Thank you to the organizers. Of course, thanks, Benjamín, who will be presenting today the first Victoria Masterclass. And we are extremely, extremely happy. We are super excited about all the opportunities that advanced technology offers for the protection of nature. And the protection of nature is precisely the core of all that is at Victoria's heart. Our purpose is using the best of technology to advance the protection of nature on the dark planet. So that's why this alliance is extremely, extremely relevant. Thank you so much.
Thank you, Christopher. Well, you know, we now go with today's webinar, and today's webinar is going to be conducted in English. You know, with this addition, this is going to be in English, but in the following sessions of the webinars, we're going to have the alternative to have simultaneous translation. For now, will be only in English. So you know, we are welcoming today Benjamín Najar Jr. He's the CEO of Thrusters Unlimited. He's you know, a very young and enthusiastic entrepreneur today, and very well, you know, well versed in space and aerospace industry. So today's subject will be how satellites can help us save nature. So you know, we are very, very happy to have Benjamín, and also we're gonna have the next week at the same time. We're gonna have the webinar actual situation of supply chain at a global level in the aerospace industry by Francisco Robles. He's a general manager of aerospace of JAS worldwide, and he will be here on the next week. So you know, we will be also very happy if you can join us from the different platforms that we're in. You know, from FEMIA's platform and also from the Victoria Land platform. Okay, next one is just a little word about FEMIA. FEMIA is the Mexican Federation of Aerospace Industry, and it's a private nonprofit organization that joins the main companies in aerospace industry in Mexico in the areas of manufacturing and maintenance, repair and overhaul, engineering and design, among other services. We have a membership of over 110 members, and you know, our members account for 80% of the total national revenue or national exports from the aerospace industry in Mexico. And of course, we collaborate with many organizations. We have a nationwide representation in Mexico. Also, you know, I would like to show some of our members in the next slide. You know, you may recognize some of the logos. The other ones that you may not recognize are equally as important, as they conform the aerospace industry ecosystem in Mexico. Next one, you know, we have different work groups, you know, from promotion to external trade, supply chain, space, innovation and technology, talent formation, and MRO and the technical commission. Those are different working groups within FEMIA. And also the staff, you know, I would like to introduce, first of all, you know, the chairman of the board, René Espinosa, and also Pamela Arellano, she's the operations director, Mónica Vega, the promotion director, Enrique Maldonado, he's the supply chain manager, Mariana Gonzalez, he's in charge of membership, and Marta Ortuño, director's assistant and project management. We are, and of course, with Liscano, you know, we are all here to serve you. And a quick reminder, just to for you to you know, save the date, April 26 to 29, 2023. You know, we have the most important aeronautical aerospace event in Latin America, which is FAMEX. FAMEX is a Mexican aerospace fair, which is basically the national showcase to the world of Mexican aerospace industry. You know, if you want to get acquainted, you know, firsthand with the aerospace industry in Mexico, you have to be here. It's in Mexico City. France is our partner country. If you would like more information, you have the QR code so that you can access more information. Mark your calendars. Don't miss it. And also, we're going to have a Q&A session at the end of our presenter today. And, you know, we would like if you could give us a quick note about what organization represent and where you connecting from. Just, you know, as a simple message to our chat. We're going to have any comments or questions during our today's presentation. We would like to have them through our chat so that we can actually have those questions on the Q&A session afterwards, the presentation of our exhibitor today. Today's presenter is Benjamín Najar Jr. He's the CEO of Aeroespacio.net, which is basically a leasing, aircraft leasing company, you know, from a commercial, passenger, and cargo aircraft. And he's also president and CEO of Thrusters Unlimited, which actually is in satellite systems, you know, Earth observation satellite systems. Basically, they are designing, manufacturing, and managing satellite platforms, and also they are also getting into the launching promotion. Nowadays, he's part of Mexican aerospace industry, and he participates in FEMIA, you know, in the Space Commission, and this his company is 100% Mexican, you know, which is a big breakthrough, given that their satellite systems have Earth observation capabilities of very high resolution, you know, which is very very interesting. Is I understand it's somewhere around 40 centimeters or so, or 30 centimeters resolution capabilities. So, you know, that being said, you know, I would like to transfer the microphone and the camera to Benjamin. Benjamin, thank you very much, and you know, welcome. This is always your home, and you know, we're very proud of you giving this webinar as well. So thank you for your help, and go ahead. It's your turn.
Hello, Liz. Thank you very much for that kind introduction and saying that I'm young. I appreciate it. Thank you, everybody, to being here and to see what we can share to you all. This masterclass is going to be a little piece of information of what we know and we have discovered through this history in space, and hopefully you can learn more or learn about Earth observation and what it's involved. So who are we? Just to give you a little background. This mission started around 8 years when we started to look at space as a different line of business for us. And we started relating with different institutions and companies around the world that had the same vision that us. And during this learning, we decided that not only we wanted to be a profitable company, but we would to give something to the planet and the nature and the people that surround us back. So in all these years that we've been generating synergies with multiple companies, we focused Thrusters Unlimited in developing Earth observation through satellite imaging. With those partners that are involved in this venture are one of the newest, that is Victoria Land, that is contributing to conserve the planet through a process that it gives the people the opportunity to help the planet and also use natural resources, not to use them as raw material, but to use them to grow them and generate also wealth. Other of our alliances is Earth Center, that it's a non-profit based on Portugal that is devoted to conserve the Atlantic Ocean through ocean sensing, land sensing, and Earth observation sensing. Also, one of our partners is Geosat, which we have the co-ownership of the only private satellite constellation in which we have ownership. We are a 100% Mexican company, and the only and the first that has ownership in very high resolution Earth observation satellites. Among the partners we have is Mexico, of course, Portugal, Spain, Norway, Switzerland, and Texas, to say a few. We, as Luis mentioned, we're 100% Mexican, and we're very proud. That's also a message that we would like to send to all the companies that are thinking about space. Don't be shy and join, because you wouldn't regret it. To start with this, I would like to explain a little bit how far is our reach getting nowadays. We cover about 65 countries serving as Earth observation, 165 plus customers providing services in different sectors. We have the reach for more than 30 satellites beyond our private constellation around the world, including radar. If you have heard about that, we talked about it later today. We have a service of 24/7, 365 days, so we can attend any emergency anytime. Also very important, we have a very large archive since 2009. We have over 5.8 billion square kilometers to go back in the past and do a time lapse of what has happened before and after and today. We have an accumulated of 11 years of experience of developing technology for Earth observation, and we continue to do new technologies to help our planet. What is the mission we're focused? Of course, our main mission is Earth observation through remote sensing. We perform image processing and information analysis, not only with persons involved, but also with artificial intelligence to make the process more fast and more efficient, so we can process more and more information, so we can have results of information to have well informed decision making to fix the problems that come to our world. Now we're gonna have a little overview of what's Earth observation. It's important to mention Earth observation is not only strictly focused on space. We also this was involved since the beginning. There was no satellite, so there's multiple instruments that are focused on Earth observation. So basically, Earth observation is to monitor all the nature changes made by nature or humans, so we can analyze and monitor the physical and chemical changes. That help us to see the changes and not also see the bad changes, but the good changes of the efforts that we're doing on the natural and man-made environment. The Earth observation is become more sophisticated every day. It keeps growing in a more high-tech definition. Now we have satellites, but we also have floating buoys that measure the currents and the changes of temperatures on the water. Also land stations that monitor multiple variables. Radar and sonar that can help us estimate different information, and also seismic and also global positioning systems that help the researchers to perform their applications. Earth observation now has become very crucial, one of the most important missions on space, because of the dramatic changes that the human modifications have applied on the civilization. So we need to be really focused on what's changing, so we can help the global environment. How does it work? So first, for you to understand where the satellites are operating, there's multiple orbits, right? So for example, we have the geo orbits, that these are the highest orbits. Mostly of the communication satellite, the large satellites are based on here. They are called geo because they're always working with the Earth. They're always focusing the same point. So if the Earth is rotating, the satellite is focusing in the same position. Then we have the low Earth orbit, that it's between 160 kilometers and 1,000 kilometers. That's where usually the Earth observation sensors are, because cameras require certain close proximity to the Earth in order to have a better sight of what's going on the ground. Then we have the medium orbit, that is called commonly MEO. That one is between the GEO and the LEO. It goes from 5,000 kilometers to 20,000 kilometers. Then we have the polar orbits and the solar synchronous. What does that mean? That it's polar because it goes north to pole or south to pole. So if the planet is turning around like this, the satellites go up and down, so they can cover all the planet in a certain period of time. Then the solar synchronous are called like that because they're trying to fix what the sun is doing. So they're always trying to have the light on their side. This is just a little explaining on where the satellites are operating. Then what's multispectral cameras? Earth observation satellites usually, well, there's radar and called SAR, and there's also optical, that is the cameras. What do the multispectral cameras do? They use the reflection of the sun in the objects on the Earth and return that light to the camera and got processed inside in different layers. So you have different channels or bands, that's how they're named, when you can join them together and make an image and get information to process, or you can separate them as different layers to get different information. So difference a panchromatic camera that centralize all the information in one layer. This was developed originally for the military, for target identification and reconnaissance, but it was seen that it was also more useful for other purposes like is used today. That also type of technology is used. Maybe you've wondered how they analyze old documents or old paintings. They use the same technology, so they can break apart and use information, for example, to see how old, of what quality, what type of material are made of. Then after it was transferred to space, what they do is that they are called remote sensing. When we call remote sensing is that they're in a space platform. And as I mentioned, the multispectral means that has different bands that can be separated at a difference as the panchromatic. Let's go. If you can see down below, that's an example of one of our cameras. This specifically is located in one of our satellites, the Geosat 2. Then here's a little, there's many more bands, but this is the more common, that are the blue, green, red, near infrared, mid infrared, far infrared, and radar. So the blue is usually used to see in depths up to 5 meters in clear water, and also see atmosphere observation. The green is usually used for vegetation and deep water onto deep depths on 30 meters. So we can see inside the water, but down to 30 meters in clear water. The red is usually used for man-made objects and soil and vegetation as well. Near infrared red, we're gonna discuss a little bit more of that, is used for vegetation. Mid is also for vegetation, but with some different parameters, like forest fires. Far infrared, you can see the moisture on the land that also combines with the other three. It generates information that we will discuss a little bit more in the future. And radar, that is the other side of the coin, that is used. This one works in the night as well, but is more to see volumes on a terrain and can show volumes of specific land. If you can see at the left, you can see an example of the different bands being separated, that you can see them, that they're in dark colors, but that gives you the information that you require. Then you can get onto blue, green, and red, also different information. But if you combine them, you're gonna see something that calls false color, but it's not that it's erroneous, but it's called false color because it's not the way the human eye sees it. A lot of researchers prefer this because you can, if you note in the red one, you can see more clearly the difference of the information you could be analyzing. And of course, in the upstairs in the up image, you can see how human perceives the images, and of course is a nicer image of a volcano. Just to give the definition of what's remote sensing, This is just to have basically the dictionary. No, it's the process of detecting and monitoring physical characteristics of an area, measuring its reflection emitted through radiation at a distance. So what is this? Is using the light and radiation that bounces into an object and comes back to the satellites. You gather that information, process it, and acquire information for decision making. Before satellites, there was the aircraft cameras that's still being in use. They're different applications, but in order to cover very large extensions, the only way possible is through satellite platforms. Resolutions in the space quality, let's say, so that we call it resolution, let's say the pixel of the quality that you're getting on an image. It depends, what depends on this, the quality of the camera, the power of the camera, the size of the camera, the power of the satellite, because satellites, these remote sensors are always active, so they require a large quantity of cooling so they can be working all the time. So as large the camera, largest the satellite, because they need more battery and energy to work. Of course, the technology is advancing every day to have better systems, more efficient, and gradually decreasing the size, but there's no technology yet to have very small satellites with very powerful imagery. So this is as it works now. So you can see some examples of what's the definition, the resolutions name. No, low resolution goes from 300 meters. Then the medium resolution spreads through 30 meters to 100 meters. High resolution goes 10 meters to 30. 4 meters to 30, and very high resolution goes down to centimeters. The most powerful satellites now can probably generate 25 centimeter images, but that's very large and very complex and very expensive satellites. You can see here, down here, some example of 10 meters, how you can see a cargo ship, and then you can go to the difference to 1.2 meters. So you can notice that you can start counting containers and seeing details that you cannot see in a low resolution or medium resolution capability. It's important to understand what defines those sizes, right? Because naturally, if you say 10 meters, we would think that it's the height of how close we can get, but no. If you imagine a picture when you're in your computer and you enlarge it, when you get to the pixels, when you can see the squares, that's what we're talking about. So for example, if you have 1 meter resolution, it means from the center of the pixel to a corner, there's a meter. So if you see it like a screen, when you say this screen is 6 inches, well, this pixel is 2 meters resolution across that pixel. That's how you can understand how the pixels work. So in this case, if you go in one of these images that has 40 centimeter resolution and you open it as most as you can and you get to see the square, that means that square is that size of the resolution we're discussing. During these processes, technology and different data analysis and companies of data analysis, like including us, we're always continuously developing how make better the images. So one thing is the natural, the native resolution that the satellite comes to you. If I give it an example, a reflex camera has an optic lens that's what gives you the real resolution of what you're looking. But then you have a digital component. The one is imprinted on a digital version. You can manipulate and play with information and the metadata to make it better. So what we do here, and we managed to develop technology and finally producing it with artificial intelligence, we generated down to 40 centimeters of super resolution from our native 1 meter resolution. It's important to note that one of our satellites, the Geosat 2, is a very powerful satellite among the satellite communities. It's the only privately owned that can generate this kind of information. You can see this image is a football playground where you can, I don't know if you can see in your screen, but you can notice the lines of the field, that those lines are 12 centimeter wide. So you can see an idea how close you can get to see what's happening on the Earth. Now let's talk a little bit of satellites to understand how they work or what's their characteristics. I'm using an example of our satellite because that's what I know best. As I mentioned, it's an optical satellite, multispectral. It is very high resolution. We can go down after process to 40 centimeters. We can cover images of 12 kilometers wide for around 800 kilometers tall. We have a very high resolution, naturally 1 meter. We have 4 bands, red, green, blue, and near. That is near infrared. We can produce up to 100,000 square kilometers per day of information. We can the revisit that it's discussed here is one time that passes the satellite in the same spot on the world. This is 2-day average. It depends where the image is required to be taken, but it can go down to 1 day. That it's very, very fast, talking on space constellations. As I mentioned, now we can produce the super resolution of 40 centimeters. Important to mention that this satellite is a 300 kilogram satellite. For you to give you an idea, the common discussed CubeSats are up to 10 kilograms. So you can have a comparison of sizes. Of course, there's satellites that weigh 5 tons and they're the size of a bus. Now let's talk about Geosat 1. This is also an optical satellite. It has a medium resolution. This generates 20 meters resolution native. But the special component of this satellite is that we produce a very large swath. So we can look at a very large pond, a small fish, and then we can go to the microscope that is the Geosat 2 and focus on that specific object. We have a 650 kilometers wide that I believe is one of the only few that can produce that, up to 1,000 tall images. It has 3 spectral bands. This one has red, green, and near infrared. This satellite is very used for agricultural and nature and forestry focused exploration. With this satellite, we can produce up to 5 million square kilometers a day, and it has a average of 3 days revisit worldwide. And this also, as I mentioned, can go down to 2 days, depending on what part of the planet we would like to explore. Now, I would like to give you an example of how these pictures are taken and every passes that the satellite do. An example, if you go to the left, is an example of Geosat 2. So every stripe you see is a passing of the satellite. Every stripe is a passing of the satellite. So in this example, it would take around 2 weeks, 2 to 3 weeks with no clouds to process in this example, Mexico. And in the right side, you can see an example of Geosat 1. As you can see, the bands are much lengthier. As I mentioned, that the swath is very extent. Not in the Mexican case, but in some countries, with one pass, we can cover all the extent of a region. In the Geosat 1, we can probably do a whole Mexican country around in a week with no clouds. So our main subject, now we have understand how this works, what we use, where it comes from, and now let's discuss a little bit how we're going to help the planet with this technology. There is infinite application. Well, maybe not infinite. Maybe the imagination is the limit. But every day, new applications are built to use the instrument. One of the most common uses are the following. For emergency monitoring and prevention, you can oversee fires when they start, where are they evolving, how to stop them, and then to assess the damage of the fires. We will see some examples later on. Floods, we can anticipate a flood. Even we did in the past, we've done tsunamis. We can see a tsunami coming, so we can alert a city or a country of an emergency that it's coming, and make awareness so they can take the measures to avoid the less damages. Volcano eruptions, we can also monitor not only when it happens and where are they spreading, but we can constantly monitor the activity of volcanoes that we're going to see an example also in the future. And also the underwater volcanoes, as we mentioned, one of the bands they can be used to see underwater in clear water, so we can see where the volcanoes and the currents are taking the toxicity, so we can avoid those areas and help to aid the solution. Earthquakes, of course, can be used to assess the damage and also advise where to deploy the assistance, because sometimes you cannot only get into air, but to get to Earth, you need a landing field or a landing space, or if it's by land, how to deploy the help through what roads are not broken, which lands are stable. So that helps also for that. Sustainability and development, urban-rural interaction. Where are the cities growing, if they're growing correctly? For example, in Japan, there's I don't remember the name of the volcano, but it's a cultural situation where the people living there believe that the volcano, if it erupts, is going to go to a side of the mountain and not to the side they're growing. So all the population goes to that side. So we can also analyze profiles of why and how are urban growths going where and why, and probably helping to make the better decision of what they're doing. Change detection. We can see man-made changes, and to control the cadastral monitoring to see that the cities are continuously following up the regulations. Clean renewable energies. We can also monitor, for example, that we're going to see in the future and of the presentation, we can see fields of different generators of energy like solar panels or aeolic. Maritime monitoring, pollution. Where is because sometimes we can measure by chemistry and analysis that the waters are contaminated, but where is that coming from? We can see where it's coming and attack the problems from the industrial point of view. Illegal fishing. Illegal fishing is a big problem because affects the oceans and the waters reserves of how the ecosystem works if it's not done properly. We can also monitor, so the law is applied and it's not happening. Piracy, that's also a very important situation that we can use, that we can well show you an example in the future how can be avoided. Then, as I mentioned, urban and cadastral control, industrial development, plant control for the population. Then agricultural resources, precision agriculture, crop estimation, hydraulic resources. Water is now the wall of the oil, the petrol of the world. We need to take very good care of the water. Risk control. We can do analysis that is very accurate from a very, very far away perspective. Environmental monitoring. There's pollution censoring, spill detection on oil rigs. If it happens, how can we make it better? International agreements. For example, if there's a treaty that establishes disarming of nuclear missiles and have to be on site and the look of the humans, you can monitor that it's happening and it stays that way. So you can follow treaties. Then One of the examples that I want to give you is agricultural precision, but because one component of taking care of the planet is also taking care of the resources and not ruin the land and not ruin the water and conserve it. And also food is very important for the people. So we need to make sure that the land is used very efficiently, producing more crops, healthy crops, larger crops, and not wasting the natural resources like water. The optimization of our total resources is one of the things that Earth observation does through analysis of the images. We can help the farmers to do a precision farming using all the land efficiently. Also, we can estimate the crops of what they're doing in their fields to tell them how large is going to be the production, because sometimes also that's a problem when you have lower production or overproduction. A lot of it goes to waste and you use water that went to waste. Hydraulic resources, where needs more water, where it needs less water. The irrigation control. Also, we can anticipate illnesses of the plants. Sometimes agriculture, when you see the illness on a plant, it's already too late, and you're gonna try to mitigate the damage. But in this case, we can anticipate when it's starting and help the industry to stop it before it gets damaged. This is one of the examples that is used, that is called the index, NDVI index, that it represents normalized difference vegetation index. What does this do? So each plant gives a reflection of a different color. So each plant is going to have a slightly different color. So that way we can know what type of plant, having a sample, we can say and know what type of plant is growing there, and is it healthy? Is it growing well? Is it multiplying? Is it getting lower production? So this is very important also for forestry. So we can see if it's growing the population or decreasing, and take charge on making the changes and appropriate changes to do that, and which is one of the missions of Victoria Land it's focused on. And this way you can take care of the land and the production and helping also the farmers in the way. Many programs around the world are being done for farming. In Mexico, we're promoting to do that. We hope that it's something that's be growing, but it's very important to maintain the natural resources that we use every day. Now, another example is the maritime monitoring. As I mentioned you before, we can look at a little fish in a big pond and then focus. Here's an example that we do in Europe. Some of the ports we monitor. This is an example of Singapore. So you can see all the traffic of the cargo ships waiting to get docked. And in the right, you can see the Suez Canal in a more close-up version. So we can see in a very large and then focus in the little. And another example of changes, we can see at the left, the little tiny point there is that base that was constructed in 1 year. That was just an island and then become an Air Force base. This is another example that can be done. If you can notice, very hard to see in the extensive oceans to find little things, so we can find them and then focalize in the little things. Here we have an example talking about space. We have the drone bark that uses floating for the SpaceX launches for the landings, and the operation ships that support the SpaceX landings. This is one close-up. We can monitor the lines of the ship, the commercial lines of the ships. This is on the Gulf, of course. This is an example of 40 centimeters. Now, discussing of water pollution, what I was telling you is that we can know that it's polluted, but where is coming that pollution? So in this example, we can see where did started and where is it spreading. So we can assess not only the problem, but cure the cause. And a lot of problems in this sense is industrial processes throw a lot of waste to the oceans, and to find them is very hard. In this example, I don't know if you remember, not much time ago, in the La Palma Island was a very, very important disaster. Was the volcano erupted, and basically all the people living there had to evacuate, and it was a very large damage. And we were able to assess the damage, and we can know where the damage is going to go. In this example, we're going to see, we did some monitoring here to see what the lava destruction was going to generate and advise the local authorities. This is another example of volcanoes. This is the Popocatepetl and Iztaccíhuatl. They're in Mexico. These are very famous landmarks of Mexico. Those volcanoes, the Popocatepetl is active, so it requires constant monitoring, and it's showing activity often. This is another example of how we can help to monitor the nature and help it recover as well. This is a very, very large fire that damaged Avila in Spain. So we can know what extension damaged the forest and how to react, try to recover it, and see what areas were in damage and where we can start rebuilding. In this case, it's another example of a fire. You can see how it was before and it was after. So we can monitor the changes. And this also includes, as we discussed, how humans develop industrial sites, if they're not affecting the environment, and take action before it's too late. In this case, it's California. We can also, we're not a meteorological information center, but as you can see, we can also see the storms that are approaching and what activity they're having. This is one example. Also, a very important task is to monitor the glaciers and the melting of the ice, so we can see gradually how has changed from the past with our archive, and then how is it moving, if what we're doing is helping and stopping or decelerating the melting, and if not, what to do. And the most efficient tool is the satellites, because to deploy constantly big and large groups of investigation groups is very expensive, and it's a very, very hard work that can be simplified and efficiency with the satellites. And in a certain point, you would say, well, satellites is very expensive. Yes, but now the democratization of space and the disruption of technology has led us to lower extremely the cost of this type of tools. So all industries, private or government, can use it more often. The thing is, we need to spread the voice that this is reachable and can be used in a more common way. This is an example of, let's say forestry. No, if you can notice the red dots, all of that is nature, different type of natures that are growing around a desertic site. This is the Teotihuacan pyramids that probably everybody knows about them. This is an example of how can you mix the natural colors with the index to know where is nature growing, and then you can assess if it's growing or decreasing and take actions. In this case, we're looking at the water path. You can also monitor the rivers, the lakes, to see what's happening, if they're lowering, if they're increasing. If a river had one ramification that is not nurturing anymore a municipality, why is happening? And the easiest way to do it is through space, and more efficient to look the problem and assess it. We can monitor as well the deserts, what's happening in the deserts, the water situation, if it's getting better, worse. We can also monitor the fauna. Illegal poaching is a big problem in some areas. We can also conduct monitoring of protected areas to oversee that situation, because sometimes what happens with the monitoring or the patrolling of situation is that you can cut an action, but you don't know where the source comes. So with the satellite, we can see the action and then what path that source came from or where to, so we can know where's the niche of the problem. We were talking about renewable energies. Here is the Gansu farm, wind farm that is being built. If you can see the windmills being assembled in the region. So you can see how it gets developed and the status. We can monitor the health of the systems as well. For example, in solar panels, we can see if a panel is broken and which panel is broken, so we can help aid the maintenance instead of looking at all the panels every day in a tremendous effort in the land. As I mentioned, we can see the water reserves, how they're working, if they're contaminated, they're not contaminated, how they're healthy or not. The coastal lines, we can also monitor that. We can also find archaeological sites from space. Sometimes you've noticed that they say, oh, we discovered this archaeological site that was lost in the jungle. Well, that was probably something happened by mistake that they stumble into, but we can look for sites, or not look, but find them more efficiently, and also see that no illegal activity of trees are being taken away from the site. So we can help also assist the archaeologists to find and conserve the sites. This is one of the examples in Puerto Progreso. Probably you identify Merida. This is very close to Merida. This is the beach side where everybody goes to the holidays. This is the one of very important ports in Mexico, and it's growing every day. So we can monitor the activity and see how it's growing. What are they doing? Who's doing other things in other parts of the world? So we can also oversight different developments and cultures. This is another example of 40 centimeters. This is the Madrid airport. As you can see, it's very, very close to what we can see. We can see what's happening and how it's operating. This is another example from the Mexico City airport. So basically, as you can see, these tools can be used for every good purpose that you focus your mindset. So also I invite you, if you have an idea, to share it with us, and we could probably make it work and develop new aids for the nature. This is my last slide, but I would like to invite you because, okay, we know what we do. So how can everybody work on this direction? Well, I could recommend you to support ONGs around the world that do this kind of efforts to conserve the environment. Also, Victoria Land is doing a great effort going in the vision to help the nature in a way that is not only helping, but usually helping requires an effort from somebody, an investment, donation. But what Victoria Land is, instead of using the natural resources to destroy them and generate products, it's making the nature to be famous and also help you generate wealth. So they're proving that is not contradictory, helping the planet and helping others. It can be done. So I invite you to go visit Victoria Land, that we are partnering as well with them because we believe strongly in the mission. Get into their website, get close to them. I'm sure they can explain you better than I. And I would thank you for your attention and coming to this forum and trying to learn a little bit of what we're trying to accomplish to help our planet. Thank you very much.
Thank you, Benjamin. It was certainly a very enlightening presentation. As a matter of fact, you know, we know that this technology has been around, you know, some years now, but you know, the possibilities with new technological advances and everything, and innovations, you know, makes a breathtaking options for many fields, including environmental protection. You know, we welcome if you have any questions that you have for Mr. Najar, please share through our chat. I have one here that they're asking if you know, the Geosat satellites were named formerly Deimos, right? You mentioned that in your
Yes, that's correct. They were formerly,
you know, and they're asking if just like the satellites from Mars, you know, the two moons from Mars are Phobos and Deimos, and you know, this constellation is named after Deimos, which is a very small moon for Mars, right?
correct. That's where the names come. Yes.
Actually, I know that Deimos was kind of a in Greek mythology was actually the god of chaos and terror, right?
Correct. We're trying to avoid that. That's
that's a very good one. You're saying, you know, we have a question here that you're saying that you can help local authorities with advice, suggestions, and everything. Is that correct? How can you do that? You know.
Well, we can help different divisions of governments in different authorities, for example, for urbanism and cadastral, national security, environmental, anthropological, basically all the branches, even educational divisions can be supported by analysis of our images with process data that they would require. For example, let's say the environmental want to know how many, just a vague example, how many trees are in a region. We can assess that for them and also recommend them what that region would support, you know, how many more forests could accommodate and what species are in danger. That type of information we can facilitate, and this is in a different branches, no, national security, environmental, fishing and water. It's the world is basically we can aid any government institution to gather information to help them take decisions and make assessments for a better development. That's correct.
Good, thank you, Benjamin. I have another question from Nikita DNSE. Thank you very much. My question is, CO2 emission control and limitation is becoming more and more strict. Can you focus on CO2 polluted areas and provide information about the improvement of the situation?
Yes, it can be done, but it has to be done in a mixture of sensing, because with the satellites, you can assess what we can see and the reflection, but we cannot really quantify the grade of pollution that has to be assisted with Earth sensors. But it can be a joint program where we can help assess those problems. Yes, we can.
Another question from Techie. Are you planning to launch any new satellites in the future? If so,
well, yeah.
What lessons learned will you apply to increase the operational lifetime of the spacecraft? And also, what efforts and improvements have been made post-launch to increase the lifetime of your current satellites?
Okay, well, first, yes, we're working in a new constellation that is gonna make continuous of the operation of the systems. So we will always have satellites up and running. We're now in the process of finalizing the design and selecting what platforms we're gonna use. We estimate we're gonna be launching probably at the end of 24, early 25. we cannot say many details. It's going to be a much better platform, smaller, with more efficient, very, very high resolution. We're working on that. What have we done to improve our current platforms? New software implementation and new algorithms of artificial intelligence that we've done in conjunction with the manufacturers to extend the life of the satellites. Now we have very healthy satellites that they're looking to extend the life beyond of our planning. But nevertheless, before that, we're going to have the new constellation up and running. And in the other question is that technology now is going in another direction. Usually, when you make a satellite, you try to give it as most life you could give it, okay, because of the costs and the service that could good. But now space technology is advancing faster. So what you want to have is satellites that have a very, very nice life, but not that long, because you're going to want to replace them sooner because of technology and give the benefits of technology to the humankind, and not have satellites that have more life, but now the applications are limited against the other technologies that you could be using, using that, let's say, that space on space. That's now the trend. Very nice life, but not that lengthy, shorten life and less expensive.
Thank you, Benjamin. Perry Coblin is asking, I know the fight is greater than this, but out of curiosity, are you able to assess the CO2 weight generated by the fabrication of the satellites, Deimos 2 and Deimos 1? You know, how much CO2 is being generated by the fabrication of the satellites?
To be honest, what is the footprint of satellite build? I wouldn't be able to answer that question, and we weren't involved on that manufacturing process, that integration and all the related components that were built. The one thing I can tell you is that all the processes that are being designed nowadays in all the industry are focused on environmental protection. For example, the new rockets are being designed to pollute less on the launches. But also, giving you an example, an aircraft taking off pollutes more than an environmental launch. So it's not really a footprint that it's making a change. Probably cows pollute more than a launch. So it's more on the process of manufacturing of the components, but that is in the industrial side, and all the industry is very focused on doing processes that are environmental friendly. But I could find out the question if there's the information, but the production chain of spacecraft is very limited. So I don't know if there's a study about that.
And of course, you know, the benefits of for environmental protection that satellites can provide completely outweighs any CO2 weight.
Much. It's unmeasurable. You know, the production to the benefits.
Far more benefits.
That's correct.
To environment than that. One last question. Of course, you know that we have can satellites help? This is from Esteban Favela. Can satellites help prevent forest fires, or to help countries to extinguish them, projecting their direction, intensity, or risk? This technology is being used by now, or is it too expensive? I would like you to comment also, because many people think that this is extremely expensive and that can only be afforded by, you know, big governments and that. And with new space, I understand this is changing rapidly, and it's having you know, having these Earth observation products being more accessible to the general public. Can you talk a little bit about that?
Yes, Luis, that's a very good point. It's very important to know. It's not casualty that so many companies are building rockets, satellites. It's because the private users, now are, as you can see, in a different segments of the space sector. Now the reach of that, it's possible. Before, as I mentioned, these type of programs were only for governments with very large budgets. They did the work for 50 years of research and development. Now they have transferred that knowledge to the private companies, that we can take advantage and generate products that everybody can use. Not only big governments, even a private user can acquire images from a satellite, because now it is not cheap, I won't lie, but it's not the way it used to be, that it was huge budgets. Now, any country, any organization, any company can use it. For example, this is an example that I love to do. One of retail chains in the United States, I'm not going to mention the brand, that they used Earth observation satellites to measure their monthly ticket per visitor using their parkings. The marketing company that they hired, they used pictures of their open sky parkings, and they measure how many people go to the supermarket every day, and they estimated a ticket per capita, and they were, I believe, 1 point difference from the real thing. So now it's a tool that can be used not only for protecting the environment, for, as I mentioned, if you have an idea, a concept that might work, and we can develop it so it works. So no, the applications are unlimited, and the cost is not that expensive. It can make sense for a lot of applications. That the stigma that is super expensive is from the past.
So basically, you mentioned that using Earth observation satellite image as a raw material for developing different applications is actually a big business trend.
That's correct.
IT community.
Yeah, a lot of communities that do analytics are using the raw images to do their own investigation of information, because you don't only need to rely in a company like us that we have the raw material and we can process it. No, you can use the raw material and use it for your own purposes and design your information by yourself.
Thank you, Benjamin. And of course, if you can go back just to get Benjamin information there, if you would like to contact Benjamin directly, these are their his contact information, so that you can contact directly. And, of course, thank you very much, Benjamin. Thank you for your collaboration. It was a very, very extremely interesting webinar. Can you advance to the next one? So, on behalf of FEMIA, the Mexican Federation of Aerospace Industry, we are certainly very grateful and very honored that, to have your participation in this webinar, and learn. We always like to talk space with you, because as you mentioned, sky is the limit, no more. Space. So thank you very much, Benjamin, and we're extremely honored.
Thank you very much, and the honor was mine, and hope this information helped a little bit. Thank you.
Just to finish, just a reminder, mark your calendars, 26 to 29 April 2023, Mexico City. More information in the QR. And also, there was some people asking if we're going to get a replay of this. We certainly do replay these webinars. With some time lag, we publish this on our FEMIA channel in YouTube. So you can actually get this information, and remind you about the next webinar next Wednesday at the same time. So one thing that is very interesting for Victoria Land audience is that through the Victoria Land platform, you're gonna get an award of this masterclass participation under the Victoria Land platform. So we're very, very happy to start working with Victoria Land, and you know, please follow us in our social media, Facebook, Twitter, following the YouTube channel, LinkedIn, and of course, you know, there's a contact information of FAMIA, and you know, thank you very much for attending this seminar, and we certainly look forward to see you next week. Thank you very much. Have a wonderful day and an excellent rest of the